And now we'll have Matt Fairlie up with the next presentation. So,
okay, well, again, thanks, Nick, for inviting us to join this showcase and the opportunity to introduce Next Hydrogen to your audience. Next Hydrogen is a Canadian company. It's based in Ontario, founded in about 12 years ago. The founders, it was actually a marriage of wind farm developers and some technology guys from the electrolysis industry, and the wind guys sort of set out the challenge. They wanted really a purpose-built, purpose-designed electrolyzer for integration into renewable energy. And I think everyone on the call is probably acquainted with what that requires. It means large scale. It means flexibility. It means operating intermittently. And the team took on this challenge, and 12 years later, we're here today with units in the field and a rather interesting patented technology that I'll talk about a little bit later. Where am I today? I'm actually at a Canadian Tire site in Bolton, Ontario, where we're commissioning a 300 normal cubic meter an hour plant. That's a plant that produces about 650 kilograms a day if it's operating continuously. The plant, of course, operates around electricity market opportunities, so it's not operating continuously. Canadian Tire has purchased 3 of our units. The hydrogen is used to provide fuel for a fleet of forklifts. These are fuel cell powered forklifts. And the interesting thing about this project and what we're doing with Canadian Tire, the project started about 5 years ago. There's no government funding. This is all run off CBA, which Canadian Tire has. Though Canadian Tire is a little bit different in that they were really curious about hydrogen and how it could be scaled up as an infrastructure using electrolysis, producing green hydrogen. They also have a significant presence in retail transportation fuels. So that's where we're at. We're operating systems here at Canadian Tire. We're scaling up the company. Of course, this is a great time one can say this is one of the, in the cycle, this is a good time to be in the hydrogen business. So we're pushing forward with building our company and expanding it. But I'll just talk a little bit about our electrolysis technology, and that's really our raison d'etre. This is what we bring to the market, and we think that it's a class winner here. So, as I said, the challenge given to the team was to develop a more flexible, more easily integrated electrolyzer, and that involves building at scale, something that so multi-megawatts per unit, advanced enhanced dynamic response, and other things that one would expect in terms of what the market requires today. Now, the approach that our team did was actually a pretty dramatic departure from conventional electrolyzer architecture. So this is a picture of some of the internal components in the system. And the thing that I want to draw you to is those lung-shaped things above the circular thing. The circular thing is the cells that you normally see in an electrolyzer that produce the gas. It's a bipolar stack, so it's a stack of these things producing gas. But above it, we have built the gas cooling and gas liquid separation. So all of this is done on a cell-by-cell basis, And what that buys you is when you can, when you look at our system versus a conventional electrolyzer, and this is, I'm showing a conventional alkaline electrolyzer. We are also an alkaline electrolyzer, but our architecture can work in both alkaline and PEM. And the thing I want to draw your attention to is that the circulation of gas liquid system is actually circumferential and up through the cell. And whereas when you're looking at conventional systems, it's this very long path that goes along the axis of the electrolyzer. And of course, one would expect that the process dynamics for the electrolyzer on the left-hand side are going to be less favorable than the one on the right-hand side. And that's really the architecture that we have developed. It's patented, it's unique, but you can see that it quickly to changes in power input. Yeah, we sell product currently in the 100 and 300 normal cubic meter hour sizes, and we are going to be in a position to release the NH500, I think, in 2022. So that gives you a quick outline, quick introduction to our company. And what we're doing. As I said, we're a manufacturer of electrolyzers, large scale, and likely in looking at where our roadmap leads to next, even larger units. So something we call the green, which is something that could be built into these dedicated renewable hydrogen projects. And again, we have the flexibility because of our architecture and our ability to operate at very high specific production rates, or what we call current density, allows us to produce a very capital efficient large scale plant. And with that, I'll take questions.
All right, so there's a couple quick questions about what's the retail cost of hydrogen, and there's a lot around the fact it's intermittent. So can you maybe answer how best to answer that question?
Okay, so there's a lot going on with hydrogen and electricity these days. If you look at these large dedicated projects, where in Australia or in Middle East, you're looking at renewable power prices less than 3 cents a kilowatt hour. You're getting in the $2 to $3 a kilogram production cost based on a life cycle, on a cost of hydrogen basis. If we're looking at something like Canadian Tire, what we're targeting is less than $10 a kilogram in the vehicle. So this is a purpose-built infrastructure. That means very good capital utilization. It means electricity rates according to ICI, that's without the global adjustment in Ontario, which would put it around 8 cents a kilowatt hour. So we're coming in less than, less than $10 per kilogram in the forklift. So that includes the infrastructure, the compressors, the dispensers, etc.
Yeah, and last question, can you just give us an idea of what the utilization rate you're seeing at your plant at Canadian Tire? And I guess does it shift over the year, or what's that looking like? What's the percentage?
Well, it's still early days here, so our utilization rate is very low, because they have been testing different fuel cell systems, and now we're transferring over to this larger system. So we're in a startup, but it's when this system is up later this year, there'll be a fleet of 150 forklifts. So utilization at 150, and we're expecting between 1 and 2 kilograms per. The utilization is going to be less than 50% on the rated size of the system. They do, however, have an outdoor fueling station. So we are looking at trucks to complement the forklifts inside, the material handling equipment inside. So there'll be some shuttle trucks, and then eventually there's a, as everyone has talked, as many has talked about in this session, you know, looking at the Ontario market, looking at the electricity market, and the market here. We believe that trucks are going to be a huge player in bringing hydrogen to Ontario, and also a huge player in decarbonization of transportation in Ontario. So hydrogen fuel cell trucks. So we'll be hopefully testing some of those in the next 12 months or so.
Perfect. Thank you, Matt. And if you can stop your screen sharing.